Assalamualaikum everyone. I am Muhammad Zarul Ezham bin Muhammad Sukur. Today, I would like to solve the practice problem 3.0 question number 7 under thermodynamics topic. I hope everyone that watched this video are in a good condition and good health. The problem statement here states that refrigerant 134A enters an adiabatic compressor as saturated vapor at negative 24 degrees Celsius and leaves at 0.8 megapascal and 60 degrees Celsius. The mass flow rate of the refrigerant is 1.2 kg per second. Determine A, the power input to the compressor, and B, the volume flow rate of the refrigerant at the compressor inlet. From the problem statement, we must highlight the important things that can help us to answer the question. As we can see here, the data given is substance is equals to refrigerant 134A. The system is compressor. The S1 is saturated vapor. The temperature one is negative 24 degrees Celsius. The mass flow rate is 1.2 kg per second. And the P2 is equal to 0.8 megapascal. And the T2 is equal 60 degrees Celsius. These all are the important things that we need to use in order to answer the question. Solution A. The power input to the compressor. We can see the equation of energy balance here. For compression problem, this is the equation that we need. As we can see from the data given, we lack of enthalpy, which is H1 and H2. In order to solve this problem, we must find the H1 and H2 value. We need to use the PV diagram and refer to the property tables to find enthalpy. From step 1, we can see that the H1 is equal to 235.92 kJ per kilogram. Why we take Hg as our H1 not HF? Because the question already stated that the refrigerant 134A is in a saturated vapor condition at negative 24 degrees Celsius. Next, we need to find H2. At step 2, we can see that the P saturated is 1682.8 kilopascal at temperature 60 degrees Celsius. From the data given, it shows that P2 is equal to 0.8 megapascal at 60 degrees Celsius. But according to the property tables at 60 degrees Celsius, the P saturated is 1.682 megapascal. P2 is smaller than P saturated. Because this is the adiabatic condition, we consider the S2 as a superheated vapor region. From the properties table at table A13, we can see the H2 value is 296.81 kJ per kilogram. Solution A. The power input to the compressor. We already have the H1 and H2 value and the mass flow rate that already given from the question. All we need to do now is substitute all the value into the formula. As we can see here, the mass flow rate is equal to 1.2, the H2 is 296.81 and the H1 is 235.92. After we substitute all the value and we calculate, we can get the power input to the compressor. Final answer is 73.068 kilowatt. B. The volume flow rate of the refrigerant at the compressor inlet. The formula is the volume flow rate equal to specific volume times mass flow rate. As we can see, we already have the mass flow rate is equal to 1.2 kg per seconds, and the specific volume that we have from earlier is 0.17 meter cube per kilogram. All we need to do is substitute the value in here, and we can get the final answer is 0.2 20 x 74 meter square per seconds.